In this video, we are going to discuss about the sequences and the series. What is meant by sequence? Look at this. Sequence is nothing but list of numbers or items with a specific pattern. You see in this below examples, here that 2 comma 4 comma 6 comma 8 comma 10, 2 comma 2 comma 4 comma 6 comma 8 comma 10. And see here, by observing that the difference between these two is that 2, and the difference between these two is 2, the difference between these two is 2, and the difference between these two is also 2. Okay, now you see that next example. Here the difference between these two, I mean 3 minus 5, that is that minus 2, 1 minus 3 minus 2, minus 1 minus 1 minus 2. Here also this is that minus 2, right? So and like that, by observing here, this one is a 3 by 1, 3 by 1 is that 3, and 3 by 9 is that 3, and 20, see 29, 27 by 9, that is also 3, 89 by 27, that is also 3. So here these examples are following that a specific pattern. So that means all these is represent nothing but the sequence. Now next one is what is that a series? By adding or subtracting the terms of a sequence. So adding or subtracting means, by observing these examples, below examples, 2 plus 4 plus 6 plus 8 and so on. Here by observing that, so the difference between 2 and 4, 4 minus 2 is that 2, and 6 minus 4 is that 2, and 8 minus 6 minus 8 is that 2. So that means here before the addition, so these sequence, these numbers are nothing but satisfy nothing but a sequence. After that, either by addition or subtraction, that expression is called that series, right? After that, progression. So what is that progression? Numbers arranged in some logical pattern with logical pattern, but a fixed rule to calculate the nth term. So all of you observe this one. Here is by observing that 2 comma 4 comma 6 comma 8 comma 10 comma and so on. So by observing this one, you can say that the numbers arranged in some logical pattern but a fixed rule to calculate the nth term. And here this one is nothing but nth term is nothing but 2 into n. So here n is belongs to that capital N. So that here by substitute n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4 and so on, you can get that. Here what is that a fixed rule? This one is that a 2n is that a fixed rule. Right? So here is that means here by observing all these multiples of 2, these are that multiples of 2, and that means 2 into 1, 2 into 2, 2 into 3, 2 into 4, like that and so on. So that means the nth term is nothing but what? 2n is nothing but nth term. So in this one, by observing these are nothing but the odd numbers. These are all nothing but the odd numbers. So by observing this value, you can write it that this value will be, the nth term will be nothing but what? 2n minus 1. This is nothing but that nth term. Okay, so that means here that what is the definition of that progression? The numbers arranged in some logical pattern but a fixed rule to calculate the nth term. So this one is nothing but the progression. Now we will see some examples related to that above concepts. See here, write down the sequence whose nth term, write down the sequence whose nth term, Write down the sequence whose nth term. So here is that nth terms are given. Here nth terms are given. So what are that nth terms? So first problem will be nth term is denoted by either that a suffix n or t suffix n. So nth term is denoted with any of this one. So now here the first question will be bit number 1. See, nth term a n is equals to, this value is minus 1 whole to the power of n into 3n plus 2 whole divided by 5. This is that nth term. So now in this one you can write it that in this nth term will be, you can write that n is equals to, you write that 1. So n is equals to 1 means a1, that is called the first term. This value will be minus 1 whole to the power of 1 into, this is that 3 into 1 plus 2 whole divided by 5. Okay, so now here this value will be minus 1 whole to the power of 1 is minus 1. 3 plus 2 is that 5. 5 by 5 is that 1. So this value will be, first term is that minus 1. If you write that n is equals to 2, then we will get that second term, that is that a2. This value will be minus 1 whole square into, this one is that 3 into 2 plus 2 whole divided by 5. Now see this value, minus 1 whole square is that plus 1. 3 2s are the 6. 6 plus 2 is that 8. 8 by 5. So second term will be 8 by 5. And next n is equals to 3. If you write that, we will get that third term. Third term will be a3. This one is that minus 1 whole to the power of 3. Minus 1 whole to the power of 3 into 3 into 3. 3 into 3 plus 2 whole divided by 5. Okay, this total value will be 3 3s are 9. 9 plus 2 is that 11. 11 by 5 into minus 1 whole power 3 is the minus 1. So totally this value is that minus 11 by 5. If you write n is equals to 4, if you write n is equals to 4, then we will be get that a4 is equals to minus 1 whole to the power of 4 into 3 into 4 plus 2 whole divided by 5. Now minus 1 whole power of 4 is that plus 1. So 3 4s are 12. 12 plus 2 is that 14. So this value is that 14 by 5. So like that you can write that. Therefore what is that a sequence? So therefore the required sequence will be, minus 1 comma 8 by 5 comma, so minus 11 by 5 comma plus 14 by 5 comma and so on. So whatever you want that, how many terms you required, you can write like that. By substituting the different values of n, you will be get that different values of the terms. So if you write n is equals to 1 first term, n is equals to 2 second term, n is equals to 3 third term, like that and so on, you can be find out. And next see that one more example. Here this value will be an, nth term is given as 1 by n square. Nth term is given as 1 by n square into sine of n pi by 3. So here the second one will be, here the second one is, what is that nth term? Nth term an is equals to 1 by n square into sine of n pi by 3. Sine of n pi by 3. Sine of n pi by 3. So now you put that n is equals to 1. So here that n is equals to 1 means you get that first term, that is that a1 is equals to 1 by 1 square is that 1 into sine of, this value is that pi by 3. Sine of pi by 3. Sine pi by 3 means sine 60. So this value will be equals to root 3 by 2. So this is the first term. And next second term, put n is equals to 2. This value will be 1 by 2 square, 1 by 2 square into sine of 2 pi by 3, sine of 2 pi by 3. This value will be equals to 1 by 4 into sine 120. Sine 120 value cos of sine of 90 plus sine of 90 plus 30. That will be equals to cos 30. Cos 30 value root 3 by 2. So this value will be equals to root 3 by 8. Next, n is equals to, you substitute that 3. That we will get that third term. A3 is equals to 1 by 3 square into sine of 3 pi by 3. 3 pi by 3. So this value will be equals to 1 by 9 into sine pi. You know sine pi value will be equals to 0. That value will be, total value will be 0. Next, fourth term, put n is equals to 4. You will be get that 1 by 4 square into sine of 4 pi by 3. Sine of 4 pi by 3. So now this value you can write that 1 by 16 into sine of pi plus pi by 3. So you know 180 plus theta. Sine of 180 plus theta will be equals to minus sine theta, because this one will be in that third quadrant. In third quadrant sine will be the negative. This value will be equals to 1 by 16 into minus sine pi by 3, minus sine pi by 3. You know sine 60 value root 3 by 2, that is equals to 1 by 16 into minus root 3 by 2. So this value will be equals to minus root 3 by, this value is 16 to the 32. So that means therefore, what are the numbers of this value? What are the sequences? These sequences will be, this one will be, first one will be root 3 by 2, comma, second one will be root 3 by 8, root 3 by 8, third one will be 0, and fourth one is minus root 3 by 32, comma, and so on. So like that you can find that whatever the terms in the given sequence, you can find out from the nth term of the series. Okay, so next one, so you do that. Third one is that nth term is given as that n by 2n plus 1 whole square, n plus 2n by 2n plus 1 whole square. So all of you please try to do this problem. So here third one is that nth term is given as an is equals to this value will be an is equals to 2n by 2n plus 1 whole square, n by 2n plus 1 whole square. So everyone please try to do that this sequence. Here I given that nth term. You write that as some terms in that given sequence. Now next one is that you see a sequence of numbers a1, a2, a3 and so on satisfies the relation an plus 1 whole square is equals to an into an plus 2 plus minus 1 whole to the power of n. We should be find out that a3, and that means you have to find the third term when a1 is equals to 2 and a2 is equals to 5. So all of you see, this is that one different model question. See here what is that given expression? Here that given one is that an plus 1 whole square. And what is the meaning of this one? N plus 1th term is equals to an into an plus 2 plus minus 1 whole to the power of n. So this is the given relation between the some terms. Now you here one more given relations, given conditions are a1 is equals to 2 and a2 is equals to 5. Now you want that a3. So here we will see this one. Put n is equals to suppose 1. Put n is equals to 1. If you write that n is equals to 1, what will get its a value? See, n is equals to 1. If you write that, that is that a2 square is equals to a1 into a3 plus minus 1 whole to the power of 1. Minus 1 whole to the power of 1. In the given question, a1 value is that 2 and a2 value is that 5. Substitute these values in the below of the result. So that will be 5 whole square is equals to a1 is equals to 2. 2 into a3 minus 1 whole to the power of 1 is that minus 1. Simplify this value. 5 whole square will be equals to 25 is equals to 2 into a3 minus 1. Minus 1 you get the left hand side, that becomes that 2 into a3 is equals to 25 plus 1. This value will be equals to 26. So here 2 into a3 is equals to 26. Now divided with the 2 on both sides, then we will get that a3 is equals to 26 by 2. That value will be equals to 26 by 2 means, so 2 will goes that this one is the 13 times. 13 times. Therefore a3 is equals to this value is that 13. So your required answer will be a3 is equals to 13 is the answer. So like that you can be find out that a4, a5, a6 and so on by using the given information. Okay, once again you see this is one of the different model question and very important for to develop the more knowledge in the sequences. Okay, right, next we go to that one more question. A sequence of numbers a1, a2, a0, a1, a2, a3 and so on satisfies the relation n plus 1 is equals to 3 into an minus 2 into an minus 1. So all of you please see this one. Here what is that given relation? This is nothing but given relation. Now again you take this relation. Here is nothing but an plus 1. This is called n plus 1th term is equals to 3 into an minus 2 into an minus 1. See, this is the n plus 1th term and this is the nth term, this is the n minus 1th term. Now what is the given condition in the question? A naught is equals to 2 is given and a1 is equals to 3 is given. So by using this additional information you can find out that a2 value. So similar to the above question, put n is equals to 0 in these values. Put n is equals to 1. Put n is equals to 1 in this value. Then what will get its value? This one will be a2 is equals to 3 into a1 minus 2 into a suffix 1 minus 1 and that means a naught. So what are the given information? a1 is given and a naught is given. Substitute in this value. a2 is equals to this one is that 3 into a1 value is that 3 minus 2 into a naught value is that 2. So this value will be equals to a2 is equals to this one is that 3 square minus 4 square, that is equals to 9 minus 2 square, not that 4 square. This value will be that is that 2 square. So here this one is that 9 minus 4. 9 minus 4 is equals to 5. So here the required value will be this one. We can be write that therefore a2 is equals to 5. So like that you can find that a3 value, a4 value and a5 value, whatever you can find out. You can also find that nth term also you can find from the given information. Right, next one you see types of sequences. Types of sequences. One is that arithmetic sequence or arithmetic progression. One is that arithmetic sequence or arithmetic progression. So arithmetic progression is shortly you can represent AP. Next one is that geometric sequence or geometric progression. And next one is that harmonic sequence or harmonic progressions. Now first we will be discuss about that arithmetic sequence. Arithmetic sequence. See, look at this one. What is the arithmetic progression? An arithmetic progression is a sequence whose terms increasing or decreasing by a fixed number. This fixed number is the common difference of AP. Now we will be discuss some examples in this one. So here 1 comma 3 comma 5 comma 7 comma 9 and so on. See, observe this one. Here by observing this one, the difference between these two is that plus 2, and the difference between these two is also plus 2. The difference between these two is also plus 2, and here is also plus 2. Okay, so that means here the difference is plus 2 is there. And that means what is the difference of the sequence? You see, the fixed number is the common difference of that AP. So here this one will be common difference D. Common difference is denoted with D. Now in this one, here the difference is that minus 2, and here the difference is also minus 2. Here the difference between these two is also minus 2. Here is also minus 2. So now here this one will be common difference is equals to minus 2. Okay, now here in this one the difference between the successive numbers will be 0. This one is 0, this is 0 and this is 0. So common difference will be equals to 0. What do you say the name of that progression if the difference is that positive? If the difference is the positive, that the sequence or series, the sequence or series is nothing but that increasing sequence. Increasing sequence. So this is the first example is that increasing sequence. This one is that increasing sequence. Okay, if the common difference is a negative, that sequence is nothing but decreasing sequence. That is nothing but decreasing sequence. If common difference is equals to 0, that sequence is that neither increasing nor decreasing. So here this is that one of the special cases. Okay, right. Next we will see that nth term of an AP. Nth term of an AP. If so, what is the meaning of the first term in any sequence? That is called that is denoted with A, and a common difference is denoted with D. If A is the first term and D is the common difference of an AP, then what do you say that nth term? Say first of all, A is the first term. Here D is that positive or negative, that is the difference. Now here the next term will be, suppose you take that D is the positive. Now next term will be A plus D. Now next term will be what? A plus 2 into D, and next term is that A plus 3 into D, and next and so on. Okay, by observing this one, you can write the first term as that A plus this one is that A plus 0 into D, and this one will be A plus 1 into D, and next this one is A plus 2 into D. Okay, and so on. So what we can say that nth term, by observing these terms, you can say that the nth term will be A plus n minus 1 into D. So what is the nth term of the sequence, nth term of the arithmetic progression. Nth term will be denoted with an or tn. So therefore this is that first term. First term is nothing but a1, and the second term will be nothing but a2. Third term is nothing but a3, and so on. This one is nothing but an or tn. So finally you can write that therefore nth term of AP, nth term, therefore nth term of AP, nth term of AP arithmetic progression, that is that an or tn, an or tn will be equals to, that is that a plus n minus 1 into d. So I hope that everybody is clear this formula. It is that very important fundamental formula. Okay, so an or tn is equals to a plus n minus 1 into d. So what is that n in this value? N is equals to, that is the natural numbers. So you can write that n value is that from 1, 2, 3 and so on up to anywhere you can write that one. And next you see that middle term of any sequence. The next one is that middle term of any sequence. See, what is that a middle term? For example, you take that a small example. You see, small examples you can take. For example, if I take that 2, 3, 4, 5, 6. So here how many number of terms are there in this one? Totally 1, 2, 3, 4, 5 terms are there. The number of terms is nothing but 5. 5 means that is the odd number. In this case, by observing, the middle term will be, so 4 is the middle term. 4 is the middle term. So that here is that left and right side. So this is that equidistance from the remaining terms. From the left side, that is the third term. From right side, that is also third term. So that means here middle term is nothing but the third term. If n is that odd number, n is the odd number. N means what? Number of terms. So number of terms are the odd. Simply you can write that. What is that formula? If an is that number of terms, number of terms will be here. This one is that you can consider. This is that suppose a1, a2, a3, a4, okay, a5 and so on, a5 and so on, an. So now in this one you can write that if n is odd, if n is odd, n is odd means then the middle term will be nothing but n plus 1 by 2th term is the middle term. What is that value? So this value will be, if n is that odd, then middle term, middle term will be, I hope this middle term will be equals to, this is that a suffix n plus 1 by 2th term. Okay? That means you take that above example. How many number of terms in the above example? 5 terms are there. Okay? That means n is equals to 5. If you write that 5 plus 1 by 2, that is equals to 6 by 2. 6 by 2 is nothing but what? A3. And that means the third term is the nth term. Third term is the nth term. Now next one will be, what is that? If n is that even. So now you take that one more example. See, this one will be one more example you take. Here, if n is equals to, here this one is that 2. Here you take 1, 3, 5, 6. So 5, 7. You take that n is equals to, here the sequence is 1, 3, 5, 7, 9, 11. So all of you observe this one. Here by observing this example, here what are that? How many number of terms are there in this one? Total 6 terms are there. In this one, by observing 5 and 6 are 5 and 6 are only the middle terms of the sequence. Here that third term from the left side and from the right side. So here what are the middle terms? 5 and 6 are the middle terms. 5 will be the third term and 7 will be the fourth term. 7 will be the fourth term. Here you see that values 5 is that 5 is the third term. 5 is the third term and 7 will be the fourth term. So how can we say that formula? If n is odd, if n is odd, if n is odd, you see, if n is odd, if n is even, if n is even, then middle terms, so what do you say that middle terms from this one? By observing that above example, by observing the above example, middle terms will be first one will be total. How many terms are there? 6 terms. So a suffix n by 2 comma a suffix n by 2 plus 1th term. So these are the middle terms. So please all of you remember this one. In a given sequence, if the number of terms are that odd numbers, the middle term will be n plus 1 by 2th term. And if n is that number of terms are that even, the middle term will be 2 terms will be exist. One term will be n by 2th term and other term will be n by 2 plus 1th term. So that is the middle term, right? So I hope that this one is very clear to all of you. Next concept is the term from the ending. The term from the ending. See, here by observing that the term from the ending, see, kth term from ending. What is the kth term from the ending? So the formula is n minus k plus 1th term from the beginning. See, for example, if you take that a1 comma a2 comma a3 comma a4 comma and so on, a17 comma a18 comma a19 comma a20. So for example, if you take that 20 terms, okay, so what is that middle term? What is that 7th term from the ending? 7th term from the ending means here, that means from right to left. So here from right to left, what will be the 7th term? Here in this case, number of terms n is equals to 20. Number of terms n is equals to 20. And my question is, what is the 7th term from the ending? And k is equals to, this value is that 7. K is equals to 7. So when k is equals to 7 means now that kth term from the ending will be equals to, so 7th term, from this you can say that 7th term from ending. So from end. So what I given that formula, n minus k. This formula will be n minus k plus 1th term from the beginning. N minus k plus 1th term from the beginning. 1th term from beginning. Okay, now you substitute in this value and substitute in this value. So here what is that k value and n value, k value and n value. Okay, so substitute n is equals to 20 minus minus 7. This one is minus 7 plus 1 whole to the power, this is it. So this value will be 13 minus 13 plus 1, that is equals to 14. So that means totally what is that 7th term from the ending? 14th term is the 14th term from the beginning is the 7th term from the ending. So I hope that everybody is clear this concept. Okay. And next we will be discuss that some shortcuts in arithmetic progression. So this video will be discussed these kind of questions all will be discussed in the next lecture. Thank you for watching this video.